Welcome to Study Loop.
In this question, we're given mass of methanol, which has the formula CH3OH, and mass of water, which, as you know, has the formula H2O. First, we're asked to find the mole fraction of methanol. The way that we do that is we find the moles of the component, in this case methanol, divided by the total number of moles. So that would be the moles of methanol plus the moles of water. So to do that, first we need to change the given masses to moles. So we're going to start with 14.6 grams, in this case, of methanol. And we're going to use its molar mass. Specifically, we're going to divide by its molar mass, 32.04 grams for every 1 mole. The way you find the molar mass is using your periodic table. And when we divide these, we find that this is equal to 0.456 moles of methanol, CH3OH. Then similarly, we're going to take the mass of water, 184 grams, divide by its molar mass, which is 18.02 grams for every 1 mole, and find that we have 10.2 moles of water. So what we're going to do with these values is we're going to take the component and divide it by the sum of the total number of moles. Let's go back and do that. So we're going to do the moles of methanol, which was 0.456, divided by the total moles, 0.456 moles, plus 10.2 moles. Make sure when you put this in your calculator that your order of operations is correct, and you should get a fraction of 0.0427. Now this is unitless because we have moles divided by moles. My units cancel, and fractions, decimals, are unitless. So the mole fraction of methanol is 0.0427. In part B, we're asked for the mass percent of methanol. So the formula for mass percent is the mass of the component, mass of the component, in this case that component is methanol, divided by the total mass. So that will be the mass of water plus the mass of methanol, and that value is multiplied by 100%. This problem is a little bit more straightforward. There's no conversions involved. I can just take the givens and plug them into my equation. So I've got 14.6 grams divided by 14.6 grams plus 180, that's a plus 4 grams. And then that value is multiplied by 100%. And when I solve, I find that the mass percent of methanol is 7.35%. This value is not unitless. It has units of percentage. Finally, in part C, we're asked for the molality of methanol. The formula for molality is the moles of the solute, or this component, divided by kilograms of solvent. Now recall that the solute is the substance that's present in smaller amount. In this case, that's the methanol. Oh my gosh. And the solvent is the substance that's present in the larger amount. So I have a greater mass of water Oh, sorry, I'm still getting used to this. I have a greater mass of water, so that's my solvent. So I'm going to go back and recall that I had, I'm struggling here, I had 0.456 moles of methanol that came from my molar mass conversion. And if I want kilograms of solvent, recall that 1 kilogram has 1,000 grams. So I'm going to change my 184 grams, divide by 1,000 to get 0.184 kilograms of solvent. And when I solve, I will get 2.48 moles divided by kilograms. And then moles divided by kilograms is also replaced by a unit called the molal, which is abbreviated with an M. So this is also 2.48 molal methanol. And the way you would pronounce that is 2.48 molal. That's your solution.